people, gray hairs and wrinkles are the telltale signs. With stars, it's color and size.
So the biggest stars, the most massive stars, the ones with the most gas, live life in the fast lane. They live very short amounts of time, but they burn very brightly, and they're very, very hot, and so they tend to be blue.
On the other hand, you have the red stars, which use their energy very conservatively, last for a long time, don't glow too brightly, and those stars last for a very long time.
So by measuring the brightnesses and the colors of the stars in a globular cluster, we can figure out how old they are. And here's the remarkable thing. They're very old. Globular clusters, at least the stars in globular clusters, in many cases are almost as old as the universe itself.
Globular clusters are living fossils. They're like discovering a community of people who've been around since the Stone Age. Some stars here have been shining for 12 billion years, more than twice as long as the sun. And that's a helpful tool in placing an age on the Milky Way.
Globular clusters are part of our galaxy. They orbit our galaxy. In some sense, they're tracers of our galaxy itself. And so by the fact that the globular clusters are so old, it suggests that the galaxy is old.
And our galaxy isn't just old. It's very old. In fact, the Milky Way is one of the oldest objects in the cosmos. It's been around almost since the beginning of the entire universe, at least 12 billion years. Globular clusters also show that the chemistry of the galaxy back then was very different from how it is today.
We can measure the chemical properties of those stars. Turns out they have very low abundances of the heavy elements. Things like iron are very rare in globular cluster stars compared to a star like the Sun.
That means the early galaxy was a far less colorful place. Without heavy elements, there weren't the beautiful hues we see in nebulas and supernova remnants today. Even more importantly, it was a galaxy without life. It took billions of years for stars to form enough heavy elements for the evolution of life to begin anywhere in the Milky Way. Leaving many to wonder how the galaxy has managed to keep going for so long.
One of the puzzles about our galaxy is that we know that it's had stars forming continuously for about the last 10 billion years. But at the rate it's eating up its gas now, it's forming new stars, it should burn out that gas soon. It should run out of fuel. And so there has to be some source for new fuel.
That source must be outside the galaxy. And recently, astronomers made a startling discovery. Globular clusters aren't the only groups of stars orbiting the Milky Way. There are other tiny galaxies circling our galaxy called ultra-faint dwarf galaxies.
The reason why we haven't known about these dwarf galaxies for very long, these so-called ultra-faint dwarf galaxies, is that they contain just a few hundred stars, 1,000 stars. So you try to find a clump of 1,000 stars while looking through a mass of 1 billion stars. It's not easy. This is a needle in a haystack problem. And it's only because we have the precise maps, it's the precision of modern astronomy that's allowed us to discover these extremely interesting dwarf galaxies.
These elusive bodies may help solve the mystery of what's fueling the galaxy.
So these dwarf galaxies are whizzing around our galaxy. They're in orbit around it. Now, sometimes they get too close. And when they get too close, they get ripped apart. In fact, they get eaten, in some sense, by our galaxy.
This computer model shows dwarf galaxies as colored disks, with our galaxy in the center. Over time, our galaxy pulls dwarf galaxies in, devours them, and uses their gas and dust to eventually form new stars.
So in much the same way that a large city might sort of cannibalize its neighbors, the Milky Way is cannibalizing its dwarf galaxy population.
Globular clusters and dwarf galaxies provide crucial insight to just how old our galaxy is and how it's managed to survive for so long. These bodies were once thought to mark the Milky Way's city limits, the very outer reaches of our star city. But today, astronomers are rethinking all that. Our galaxy might be bigger than what we can see, spreading out further than we ever imagined. We're picking up our Earth and moving from our quiet suburb to a new neighborhood in the outer spiral arm of our galaxy. Here, we'll uncover the mystery of what holds all the stars in the Milky Way together. From our new address, the night sky looks a little different. The Milky Way is smaller and the sky darker. Here, tens of thousands of light years away from the center of our galaxy, we're still bound by the force of gravity.
Gravity is the force that makes any two objects want to move towards each other.
On Earth, cities are built with iron girders and concrete beams. An invisible scaffold which holds buildings up against the pull of gravity. Without this scaffolding, skyscrapers would crumble and bridges collapse. Gravity governs Earth and the entire universe. Anything that has mass has a gravitational pull. The more the mass, the stronger the pull. With 200 billion stars, the Milky Way has a huge mass and a tremendous gravitational attraction to match. So, like a building, our galaxy also needs propping up against the force of gravity.
Imagine the disk of our galaxy. If you just took a disk of stars and put it there, gravity would tend to make this disk collapse in on itself, and it would immediately just fall together. That's not what we see with the galaxy. What's actually going on is the stars are orbiting around the center, and that's what keeps them from falling in much the same way that the Earth is orbiting around the sun.
The planets in our solar system are in a delicate balance. Gravity pulls them towards the sun, while their orbital velocity wants to fling them out into space. In order to stay balanced, planets further from the sun must orbit more slowly.
If you go to more distant planets at the edge of the solar system, they're going around the sun much more slowly than the Earth is, and that's because the gravity is weaker there.
The same should hold true for stars in the Milky Way. They all orbit the center of the galaxy. But the stars in the outer arm should be traveling more slowly than those closer to the galaxy's heart.
What's interesting is that's not what's going on. The stars in the outer parts of the galaxy are spinning around just as quickly as those in the inner parts.
And they're not the only ones.
It's not just our galaxy, it's every galaxy we look at. Every galaxy we look at seems to be spinning too fast in its outer parts.
These speeding stars should be flung out of the galaxy altogether, but they're not.
That is a puzzle. This means that there's a lot more mass there that we just can't see.
Mass that produces the gravity that holds these stars in their orbits. But when astronomers look for the mass, there appears to be nothing there. Leading cosmologists like Joel Premack to an astounding conclusion.
All of the galaxies, all of the stars and gas and dust and planets and everything else that we can see with our greatest telescopes represent about 0.5% of what's actually out there. The rest is invisible. It's mostly some mysterious substance that we call dark matter.
You can't see dark matter. The reason why you can see normal matter is because light shines on it and reflects off of it. That's how you can see me. Dark matter doesn't work that way. The light goes right through the dark matter. The way we detect dark matter is because it has mass. Anything with mass affects other things via gravity. That's the golden rule of mass. That's what mass does. It tugs on other things because of gravity.
Without dark matter, the Milky Way couldn't exist.
So the galaxy is spinning. The galaxy is spinning fairly rapidly. The reason why it can spin so rapidly is because it has so much dark matter. The dark matter has a lot of mass, and therefore it has a lot of gravity, and that's what keeps the stars whizzing around. If you were to magically take all of the dark matter away from our galaxy, it would fly apart. The stars would just keep going straight, and in a very short amount of time, the galaxy would just be gone.
There'd be just a mess of stuff flying every which way. And that's not just true of our galaxy, it's true of every galaxy and every cluster of galaxies in the universe. They're all held together by this invisible stuff that we call dark matter.
So we need the dark matter. It's the glue that holds galaxies together.
The discovery of dark matter has revolutionized our picture of the Milky Way. The stars of the galaxy represent just a fraction of its mass. The rest is made up of an invisible halo of dark matter, surrounding every single star and every creature in the galaxy.
The stars are just the central region. The halo is at least 10 times bigger and weighs much more than 10 times more than all the stars and gas and dust that we can see. It's that whole structure that's the real Milky Way galaxy. And that's not just true of our galaxy, it's true of every galaxy we've ever studied.
But dark matter does more than simply hold galaxies together. Astronomers now think it binds the Milky Way into an extraordinary structure with billions of other galaxies. A structure that reaches to the very edge of the universe. We've left our home galaxy to take the Earth across billions of light years of space and time.
One of the great things about telescopes is they're time machines. Because light travels at a finite speed, when we look at distant objects, we see them as they were when the light left them.
As astronomers look back over billions of years, they see a universe teeming with galaxies. But these galaxies aren't scattered randomly through space. They cluster along delicate filaments woven in an intricate structure. A vast cosmic web that holds the answer to the birth of galaxies themselves. It's a story shrouded in darkness. Look back far enough, and gradually all the galaxies disappear.